Hello class, welcome to this video on AP Statistics test, chapter test 4. So we're gonna look at one of the versions of the test, so hopefully this will be useful to you. So for number 1, it says a new headache remedy was given to a group of 25 subjects who had headaches. 4 hours after taking a new remedy, 20 of the subjects reported that their headaches had disappeared. From this information, you conclude so let's look at the first choice here. So it says that the remedy is effective for the treatment of headaches. It says here that 4 hours after taking the new remedy that their headaches disappeared. But, how do we know that their headaches would not have to have disappeared otherwise? Or maybe their headaches disappeared because of something else, right? Or if there's a placebo effect, right? So we have nothing to compare this, right? So we can't necessarily say that it's effective for the treatment of headaches. We can't, because we have nothing to compare it to. Nothing because the sample size is too small. That's not necessarily the case. For this example, it says nothing because there's no control group. So there's nothing to compare to. So it's got to be C. The new treatment's better than aspirin. Again, we don't know because we didn't compare it to aspirin, right? So what if we had an aspirin group or a placebo group, right? We can conclude that we can't conclude anything from this little study. Number 2, we wish to draw a sample of 5 without replacement from a population of 50 households. Suppose the households are numbered 01, 02 to 250, and suppose that the relevant line of the random number table is given. Then the households selected are. So if we look at these numbers here, we want to select 5 houses, right? So and we want to from a population of 50, so from 01 to 50. So here this is one household that we can select. All right, and then we got 36. That's a number that's between 01 and 50. We got 23, so that's 3 households so far. 56, we got to ignore 56, right? We got to ignore 92, ignore 96, and then we got 23. That's 1, 2, 3, 4 households so far. Ignore 79, and then we got 08. Oh, excuse me, 23 is a repeat, so we actually technically have to ignore 23 as well, because that's a repeat. I forgot about that. So we got 08, and then we got 42 right here. So that's 1, 2, 3, 4, 5 households. That's 5. So 11, 36, 23, 08, and 42. That looks like this one right here. So the answer is B. All right, so let's look at number 3. A maple sugar manufacturer wants to estimate the average trunk diameter of sugar maple trees in a large forest. There are too many trees to list them all and take a simple random sample, so he divides the forest into several hundred 10 meter by 10 meter plots, selects 25 plots at random, and measures the diameter of every sugar maple in each one. This is an example of... you have broken up into groups in this case, based on proximity in different areas, and then you're selecting 25 of the plots at random and then doing every single tree, right? Whenever you select those, that's a cluster. That's a classic example of a cluster. Okay. All right. So number 4. A researcher for a consumer products company is field testing a new formula for laundry detergent. He has contracted with 60 families, each with 2 children, who have agreed to test the product. He randomly assigns 30 families to each group that will use the new formula and 30 to the group that will use the company's current detergent formula. The most important reason for this random assignment is that... Okay, so the most important reason for this random assignment is, so remember, why do we do random assignment, right? So the reason why we do random assignment is because by randomizing who goes in what groups, we can eliminate. We can essentially what we do is we try to make the groups as similar as possible. So you want to make the groups as close to each other as possible because you're doing it by chance. But we know that by doing it by chance, there's a chance that the groups may not be different. However, the best way to do it to avoid bias, right, is to randomly assign them, and then and there's a good chance, right, that the groups will be as similar as possible. However, there's also a chance that they may not, right, and that's why we have to consider the fact that we need statistically significant results and things like that, right, to see if, and we need replication to make sure that to eliminate that issue, right? So that's the main idea. So let's see, pick the best answer. So randomization makes analysis easier since the data can be collected and entered the computer in any order. No. Randomization eliminates the impact of any confounding variables. Randomization can help confounding variables, but that's not the reason why we randomized. You actually do need other things for that. You actually do need control in an experiment, right? So you can control these variables. So it's not necessarily that. Randomization is a good way to create two groups of 30 families that are as similar as possible so that comparisons can be made. That's what we do. So comparisons can be made, and you want it to be as similar as possible. All right, so there you go. It's got to be that one. All right, so number 5, to test the effect of music on productivity, a group of assembly line workers are given portable MP3 players to play whatever music they choose while working for 1 month. For another month, they work without music. The order of the 2 treatments for each worker is determined randomly. And what kind of study is this? This is a classic example of a matched pairs experiment, right? Where each person is their own, each worker is their own pair. So this, in a way, each worker kind of serves as their own control group, right? Where they act as their own pair before and after in other words, to compare the results. Okay, so this is a classic matched pairs experiment. All right, so number 6, a survey was done in the town of Mechanicsville to estimate the proportion of cars that are red and made by companies based in Japan. A simple random sample of 25 cars from a parking lot at Lee Davis High School was taken. Which of the following statements is correct? So since this is a simple random sample, it should be representative of all the cars in Mechanicsville. Well, the idea of a simple random sample is that you want to be as representative as possible, right? However, remember that every time you take a simple random sample and you repeat that measurement, you're not necessarily going to get the same results, right? And so you may get something that is a little bit off, and so because it's by chance, right? And so it may not be fully representative. But it would be the best type of sample that would have a chance at being representative, right? So it's not necessarily that it would be representative of all the cars, right? With certainty. Part B is if a random sample of 15 cars were taken, we would expect the same amount of variability in the proportion of red cars as we would with a sample of 25 cars. Again, that's just not true. We have sampling variability. Sampling variability is a thing, and we will not necessarily expect the same variability, because if you the bigger your sample size, the smaller your variability, right? So we would expect actually less variability if we took 25 cars than if we took 15 cars. All right, so it's not B. An alternative method for getting a representative sample would be to select the 25 cars closest to a specified location, such as the entrance to the gymnasium. No, that would actually be not representative because you're getting them close to a specific location. So that's a biased selection, right? So that's almost like a convenience where you're just picking the cars close to an area. So no. A different team doing the sampling independently would probably obtain a slightly different answer for their sample proportion. So if you had somebody else doing a simple random sample, they would probably obtain a slightly different result. So this seems like the best type of answer to provide. So I'm going to pick that one, but let me look at E. The results will be the same regardless of the time of day that the sample is taken. So no, different samples yield different results. Even if you have the same method of sampling on the same population, you're still likely to get different results due to sampling variability. All right, so that's number 6. So now let's look at number 7. A nutritionist wants to study the effect of storage time, and we have 3 different periods of time there, on the amounts of vitamin C present in freeze-dried fruit when stored for these lengths of time. 6 fruit packs were randomly assigned to each of the 3 storage times. The treatment, experimental unit, and response are respectively. Okay, so we got, they're asking for those 3 things. So it says a specific storage time. Well, specific storage time is a treatment, right? So that's good so far. And then we got the amount of vitamin C. Now, amount of vitamin C is the response, response variable. Okay, the storage time is the factor or the treatment here that we're using, which is sort of like the explanatory. And then we have it says the next part, so it can't be A, right? So I'm going to eliminate that, but let me just look at the other part. A fruit pack. A fruit pack is an experimental unit, so that's the EU. Okay, so that's this guy. All right, so it can't be that one. A fruit pack, no, can't be B because we said a fruit pack is an EU, right? It has to be in the same order. Random assignment, no. Specific storage time, okay, yeah, that was the treatment. That is the experimental unit, and that is the response. That's D. All right, so let's look at number 8. A researcher observes that on average, the number of divorces in cities with Major League Baseball teams is larger than on cities without the Major League Baseball teams. So which of the following is the most plausible explanation for this observed association? All right, so the presence of a major baseball league team causes the number of divorces to rise. Perhaps husbands are spending too much time at the ballpark. Okay, so we're looking for the most plausible explanation, right? So we don't necessarily want to conclude cause here. It says here that on average the number of divorces in cities is larger, so that's a correlation, right? So that's an observational study. This is observing. So that's an observational study, and observational studies cannot determine cause and effect, right? In general. So this is definitely not a good conclusion to make because there's other other confounding variables at play here. So let's look at part B. The high number of divorces is responsible for the presence of Major League Baseball teams. More single men means potentially more fans at the ballpark, making it more attractive for an owner to relocate to such cities. Again, there may be a completely unrelated variable that is actually accounting for the same observation. So we want to make sure that we eliminate such variables. So again, this is saying responsible, so it's saying it's causing it. So it's not that. All right, so the association, so this is an association, so that's correlation, so that's good so far, is due to confounding. You have other variables at play. Major leagues tend to be in large cities with more people. Major leagues tend to be in large cities with more people, hence a greater number of divorces. That is a good explanation, and it's explaining the idea of confounding. So it's possible that like it says here, the major league teams are in large cities, and large cities tend to have a greater amount of people, and then therefore a potential for a greater number of divorces. So that might be the confounding variable. All right. Okay, so that's got to be the best choice. All right, number 9. Control groups are used in experiments in order to accomplish which one of the following? So limit the effects of variables other than the explanatory variable on the outcome. Yes, that's what control groups do. Control groups limit the other variables other than what you're trying to study. So that's true. So this looks good so far. Part B, control the subjects of a study to ensure that all participate equally. No, it's not to control the subjects, it's to control the effects of variables. Guarantee that someone other than the investigators who have a vested interest controls how the experiment is conducted. No, it's not controlling the people. It's not controlling the researchers or the subjects. Achieve a proper and uniform level of randomization. No, control groups don't have to do with uniformity of randomization. Reduce variability in results. No, control groups are not there to reduce variability in the results. They're there so that you can compare the groups, right, to other groups by limiting the effects of variables. Okay, so we got there. So number 10, a survey is to be administered to recent graduates for a certain nursing school in order to compare the starting salaries of women and men. For a random sample of graduates, 3 variables to be recorded: sex, starting salary, and an area of specialization. Which of the following best describes a conclusion that can be drawn from this study? Okay, so we want to compare starting salaries of women and men, and then you got a random sample of graduates, and then they recorded 3 variables. Okay. Whether being female causes graduates of this nursing school to have lower or higher starting salaries than males. Which of the following? Okay, so the best describes a conclusion that can be drawn. Let's look at the next one. Let's see. Whether being female causes graduates in this sample to have lower or higher starting salaries than males. Okay, so part A is saying whether being female causes, so it's using the word causes. The main thing here is that we are doing a survey, right? And so you're just randomly picking graduates, and then you're recording the variables. This is an observational study, right? So what can we infer? We cannot infer cause and effect here because first off, the way you infer cause and effect is if you have random assignment. We don't have any random assignment here, right? So therefore, we cannot establish cause and effect. We do have a random sample of graduates, so we have individual randomization. So we have randomization of individuals, but not random assignment. Okay, so it eliminates A and B. Whether choosing a certain area of specialization causes female graduates of this nursing school to have lower, again, we have another causes, so it can't be that. Okay, we can only establish association because we have a randomization, but we do not have random assignment. Okay, so random sample means we can establish association, but not cause and effect. And randomization also allows us to infer the results to the population of wherever we selected them from, right? So in this case, we can randomize the results to all graduates of the nursing school. Of that specific nursing school. All right, so let's look at D. Whether there's an association between sex and starting salary among graduates of this nursing school. Yes. Whether there's an association between sex and starting salaries at all nursing schools. No. Not all nursing schools. Just that specific one, because that's the only one that we chose that we randomized from. All right. So now we're at the free response. So let's take a look at this. So read the following brief article about aspirin and alcohol. So aspirin may enhance impairment by alcohol. Aspirin, a long-time antidote for the side effects of drinking, may actually enhance alcohol's effect. Researchers at the Bronx Veterans Affairs Medical Center say. In a report on a study published in the Journal of the American Medical Association, the researchers said that they found that aspirin significantly lowered the body's ability to break down alcohol in the stomach. As a result, 5 volunteers who had a standard breakfast and 2 extra-strength aspirin tablets an hour before drinking had blood alcohol levels 30% higher than each had when they drank alcohol alone. Each volunteer consumed the equivalent of a glass and a half of wine. That 30% could make the difference between sobriety and impairment, said Dr. Charles S. Lieber, medical director of the Alcohol Research and Treatment Center at the Bronx Center. who was co-author of this report, with Dr. Risto-Roine. Okay, so first off, it says 5 volunteers who had a standard breakfast, 2 extra strength aspirin tablets. So we had aspirin plus drinking plus alcohol. Then we had alcohol alone. So that's what we're comparing it to. We're comparing it to aspirin plus drink plus alcohol, and then just alcohol by itself to see what it would have looked like if they just drank alcohol. So this is an experiment. We have 2 treatment groups, right? So again, the main thing, this is an experiment because treatments are imposed on the subjects. Okay, so this is an experiment. And that's really the main thing. If you say that the treatments are imposed, and then I'm going to provide an example here. We have alcohol plus aspirin, and then alcohol, right? So if you just said this is an experiment because treatments are imposed on subjects, then I would take that. Now, part B, it says identify the explanatory and response variables. Okay, so the explanatory variable is the level of aspirin consumption. What are we changing here between the 2 treatments? We're changing whether they're taking aspirin or not. In this group right here, they're taking aspirin. And then in this group, they're not taking aspirin, right? So what's changing, what we're manipulating, is the explanatory variable to see if aspirin is the cause, right? Explains rather the response. And what's the response variable is the alcohol concentration, right? So the blood alcohol content. So the explanatory variable is the aspirin consumption, however way you want to say that, whether they take aspirin or not, you can say that. And then the response is the blood alcohol level. All right, identify the experimental design used in this study. So what kind of study did they use? That's what we want to look for. So let's look a little bit more. Let's go back to the article here. So it says that they found that as a result, they took 5 volunteers who had a standard breakfast. So they had the 5 volunteers, they took aspirin before drinking. And then it says they drank alcohol alone, right? So each volunteer consumed the equivalent of a glass and a half of wine. So it looks like they used the 5 volunteers. They had them have breakfast with the alcohol, then before drinking. They looked at their alcohol levels, and then they looked at their alcohol levels when they drank. So they're comparing it to the same volunteers, right? So it's the same person being involved in the study, before and after. So you're applying the same treatment. So this is a match pairs experiment, okay? So this is match pairs. All right, so, and it says we want to justify our answer. So in this case, each volunteer was given both treatments. Aspirin before drinking, and then drinking, and then and drinking without. I'm going to put drinking without aspirin. So acting as their own pair. All right, there you go. So if you just mentioned that it's a matched pairs and the volunteer was given both treatments, then that's fine. All right, so part D, in the second sentence above is the phrase, researchers said they found that aspirin significantly lowered the body's ability to break down alcohol. What is the statistical meaning of the word significantly in the context of this study? So, when they say the word significantly, statistically significant, statistical significance means that there's such a large difference in there's such a difference in the response, right? That the difference that you see in the responses is large enough where it's unlikely to have arisen by chance. Okay, and that's the meaning that you want to make sure that you put in your explanation, is that the difference in the responses is large enough, or significant enough in this case, right, or large enough, where it couldn't have just been due to chance alone, right? And that's what you want to put in your answer. Okay, so we're gonna say this means the difference in the blood alcohol levels between the two treatments is large enough that it's unlikely to have been due to chance or chance variation. Okay, that's what you want to include in your response. The difference is large. Saying the difference is large enough is not enough, right? So you have to say the difference is large. That's one part of it. And then you have to include the element of chance, right? So that's how you get the full credit for this answer. All right, so part E. This was a controlled experiment. Describe how it was controlled and explain the purpose of doing so. So each subject is their own control, right? Because you're using the same person, the treatment A on the same person, and then treatment B on the same person. Okay, so by doing that, you're able to control lots of variables. You're able to use them as their own control group, and then comparing the blood alcohol under both treatments. So this allows you to isolate aspirin from any other variables, right? Because you're doing it on the same person. All right, so each volunteer acted as their own control group. And then allowing us to compare their blood alcohol under both treatments and isolate aspirin from other variables. Okay, so if you said something like each volunteer was their own control group, we compared before and after, or both treatments, that's fine. Okay. All right, so number 12. So we took care of that study. Number 11. So number 12, high blood pressure adds to the workload of the heart and arteries and may increase the risk of heart attacks. If not treated, the condition can also lead to heart failure, kidney failure, or stroke. We wish to test the effectiveness of the angiotensin converting enzyme, ACE inhibitors, as a treatment for blood pressure. It is well known that men and women may react differently to common cardiovascular drug treatments. What sort of experimental design would you choose for the study and why? So if it's well known that men and women react differently, then you're going to need to block by gender, right? So or block by gender to reduce the impact, right? The variability rather. So since we know that they react differently, we're going to break them up into groups, and we're going to block them by gender. So if we're going to block, that means the experimental design that we're using is a block design, a randomized block design. Okay, so our blocking variable being gender, right? So I'm going to put block here. So we're going to do randomized block design. Okay, so what sort of experimental design would you choose for the study and why? Randomized block design in which we block by gender. And it says why. So this is the next part of the question. This will reduce impact due to differences in responses between men and women. Let me put in here impact on variability. Or let's do this, and let's say reduce the impact due to reduce the impact due to differences in responses between men and women, that they might have on variability. The variability that comes from random assignment. Or I'm going to say reduce the impact. Let me adjust my response, sorry. This will reduce the impact that the differences in the responses between men and women might have on variability. So in other words, if we randomly assign them, we're going to have variability in the results, right? Because of the fact that there's men and women and they react differently. And so what we want to do is we want to reduce the impact that the differences in the men and women the differences in the responses would have on the variability, right? So that's essentially what we're doing. All right, so for part B, explain why an experiment involving 600 men and 500 women is preferable to one involving 60 men and 50 women. So we got a larger number of subjects. This is called replication, right? So I'm going to say replication, or larger number of subjects. So replication decreases the impact of I'm going to put decreases the impact of variation due to random assignment, or the differences in the groups, right? It decreases the impact of variation due to random assignment on the experimental results. This enables us to distinguish the effects of the treatment. All right, so in other words, what replication does is when you're randomly assigning people into groups and things like that, and you're going to have some variation in those groups just due to chance. And what you want to do is you want to mitigate that, the impact that has on the results. And so you want to get enough people where it kind of averages out or cancels out that effect or reduces that effect, so that you can see, like, is it due to treatment or is it due to the fact that there's a little bit of variation in the groups? And that's what replication does. All right, so that's part B. So part C, it says, assume that 600 men and 500 women suffering from high blood pressure are available for the study. Describe a design for this experiment. Be sure to include a description of how you assign individuals to the treatment groups. So it's important to get the full credit. You want to talk about how you actually do the random assignment. All right, so you don't. It's not enough to just say, "Oh, randomly assign these guys into these groups." You have to explain how you're going to randomly assign them. So you want to be very detailed with the response. Okay, so first off, since we're blocking, right, we want to make sure that we explain that we're blocking. So create 2 blocks. Consisting of 600 men and 500 women. Or yeah, let me say create 2 blocks for the 600 men and 500 women. Okay, blocking by gender, right? I'm just going to put that in parentheses. All right, so we're blocking by gender, and then we have our 2 blocks. So within each block, assign men with the numbers Now it says we're gonna describe how we're gonna do this random assignment. So let's do we can do random table, or we can do a random number generator, which that's where I'm going to do the random number generator. Numbers 1. I'm going to put with unique numbers from 1 to 500, or 600, sorry. And women with unique numbers from 1 to 500. Use a random number generator to generate 300. We want to split the men into 300 and 300, right? For treatment versus not treatment. Treatment A, treatment B. And then for the women, 250, 250, right? Since we are blocking here. And we're assigning them into 2 treatment groups, rather. So use a random number generator to generate 300 numbers between 1 or 300 different numbers. Let me put different numbers. Between 1 and 600. using these numbers to select men accordingly. Okay, so we got the men now. All right, for women, randomly generate 250 different numbers between 1 and 500. Selecting the women corresponding to those numbers. Okay, so we talked about women, we talked about the men, how we randomly selected. So that's a description of how we're selecting them. And now we're about to explain how we're gonna assign them to the groups now. Okay, so now let's explain how the 250 women and then the 300 men. We're about to explain how we assign them. So now we got them the 300 and the 250 women. Now these women and these men are gonna go to the treatment group. So they're going to be treated with ACE inhibitor, right? Okay, so I'm going to put these subjects will be treated with the ACE and the remaining with placebo. Or we could say remaining will receive a placebo. Okay, so now we described how we assign to the treatment groups. So we've done that already. Okay, so now we can go ahead and finish off as and compare changes in blood pressure, BP, between both treatment groups. After accounting for differences in men and women. Okay, so we talked about the blocking. We talked about how many in each block. We talked about how we select those individuals and randomly assign them to treatments. And then we talked about comparing the blood pressures and between the groups. Okay, so that's the overall experimental study, the design. All right, so now let's look at number 13. So number 13 is about bias. So bias is present in each of the following sampling designs. In each case, identify the type of bias involved and state whether you think the result obtained is lower or higher than the actual value for the population. All right, so it says a political pollster seeks information about the proportion of American adults who oppose gun controls. He asks a simple random sample of 1,000 American adults, do you agree or disagree with the following statement? Americans should preserve the constitutional right to keep and bear arms. All right. So what if they, let's just suppose maybe it says, do you agree or disagree with the following statement? Americans should keep their right to keep and bear arms, right? So here it says they include the word constitutional, right? So instead of saying Americans should be able to keep and bear arms, they include that term constitutional right, okay? So in other words, that would enable a more positive response to that survey, right? More people are going to agree. And we can see that here. It says 91% of people said agree. So this is likely an overestimate, right? So it says that is 910 out of the 1,000 oppose gun controls. Okay, so they, all right. So in this case, this is a question wording bias, right? Question wording bias is the way you word the question allows for a change in the response. So, the term or the phrase constitutional right I'm going to say may generate a more positive response to the question. So I'm going to say, therefore, the 91% is likely an overestimate. In other words, greater than an overestimate of the true amount or the true proportion. That oppose gun controls. All right. So it's likely that it's greater than, and it's the reason this being is the whole constitutional right. They could have just said that. They could have just worded as, do you agree, do you want to keep and bear arms or something like that? All right, or instead of including that phrase, which may have skewed in one direction. So now part B, it says a flour company in Minneapolis wants to know what % of local households bake at least twice a week. A company representative calls 500 randomly selected households during the daytime and finds that 50% of those who responded bake at least twice a week. Okay, so this would be non-response bias because we have people that are effectively not either not able to participate or not willing, or we're effectively singling out people, or rather non-response bias because there's people that are not able to respond right to the survey. It says that there's 50% of those who responded. That means that there are people that did not respond, right? And you're doing it during the daytime, so effectively what people can't answer during the daytime, they're unable to, that's going to affect the response of the survey. So we're going to say it's non-response bias. Since there are those unable to respond to the survey, or unwilling, that's also as well, or unwilling. So we're going to say there are those unable to respond or unwilling during the day. During the daytime. It's possible that those unable to respond are at work, are working, and thus have less opportunity to bake. Those that responded may have more time to bake. Which makes
the 50%, likely an overestimate. Of the true proportion. All right, so if you said non-response bias, there's people that can't respond during the daytime, and then you say, okay, people that responded probably have more time to bake, which would make it an overestimate. You can say something like that. You don't have to say exactly how I worded it, but as long as the elements are there and it makes sense. All right, guys, that's going to do it for the video. I hope you found this useful and informative, and as usual, I'll see you in the next one.